Okay, so we're looking at related rates problem on page 146, section 3.5. It's number 16. They say we've got a water trough that's shaped like an isosceles triangle in the cross section. So something like this. It's 10 meters long. So like that. And we're filling it up as we go along here. They tell us that the base of this isosceles triangle is 1 meter, or the width of it, and that the height, or the depth of it, height I suppose we'll call it, is 0.5 meters. Now the volume of a shape like this is going to be the area of the face times the length of the thing, so it's going to be 1/2 the width times the height times that 10 meter length of this trough. We're also told in the question that the change in volume over change in time, or the trough, is being filled at a rate of 0.4 meters cubed per minute. So we're given dV by dt, and we're asked dH by dt, which is how fast will the water level be rising at a certain instant. They do try to mess with us with units a little bit, because they give some units in centimeters and some in meters. So just be careful with that you have everything in meters. Now, in our volume equation here, we have V, which is fine, W and H, which is a bit of a problem. We don't really want W in there. So the relationship that we have is that the width of this triangle over the height is 1 meter over 0.5 meters. In other words, width is twice as big as the height. So what that allows me to do is to rewrite my volume equation as volume equals 1/2 2h times h times 10. So I just replaced the W with 2h. Now, even that can simplify a little bit to just say that it's 10h squared. A surprisingly simple equation for the volume of this trough here. Now, when I take the derivative with respect to time, I get dV by dt equals 20h dH by dt. I have some given numbers in the question, like the dV by dt is 0.4, and I have also been given the fact that the water is 40 centimeters deep at this instant. So the height, or the depth of the water, is 40 centimeters, which is 0.4 meters. So I put in some numbers here. I've got 0.4 is my rate of dV by dt, also from the question, equals 20 times 0.4 times dH by dt. And if I solve and divide, I end up with 1 over 20 as my rate. dH by dt equals 1 over 20, or 0.05 meters per minute, or if you prefer, dH by dt is 5 centimeters per minute. So at that instant that they're mentioning, our depth of water is going up by 5 centimeters per minute.